Good evening, everybody. Welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and of course, the darn good friends of York University. I'll be one of your three hosts this evening. Good evening, my name is Paul Delaney, and we've got the ever-ready Sana.
Hi.
Hi, there she is. Not to mention the wonderful Gagan.
Hi.
A party of three this evening. We are broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. And it's Monday night. It's therefore Science Night in Canada, where the lineup is, at the moment, entirely Canadian. Starting with ourselves, York Universe. On to Western world's quirks and quarks, not to mention science for the people. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, which is Tuesday morning 1 a.m. Eastern Daylight Time, or more to the point, Universal Time at this time of the year. The York Universe production works in concert with our online public viewing program. Well, it normally does, but as we will tell you in a moment, it's not with us tonight, but that's okay. It's run by the Observatory team, and it is normally running from 9 till 10 o'clock, same as us here local time. Normally you would head across to observatory.info.yorku.ca and you can go over there because there's terrific content, but as I say, there's no live online public viewing tonight. More about that soon. Our broadcast is powered by and is in partnership with astronomy.fm, the voice of astronomy. If you've got any questions or comments about our past shows, or if you have suggestions for future topics, by all means drop us a line at observe@yorku.ca. You can always connect with us on Twitter or Instagram with the handle @York Observatory, and Facebook is @Allan I Carswell Obs. All of our programming is free, but if you would like to make a donation, see the website observatory.info.yorku.ca and look for that big friendly button there in the middle of the page. Okie dokie, there's the intro. Ladies, we are at episode 496. The countdown is on, T-minus 5 episodes and counting to that big 500. Can you believe it?
That's crazy. It feels like, I remember when there was I think it was the 400th episode, and it really doesn't seem like it was that long ago.
It was over 2 years ago, Sana. You're, of course, showing your age now.
It honestly, when I saw the email announcing the 500th episode, I was shocked. It was like, no, the 400th episode wasn't that long ago.
Do you remember when you joined us, Gagan, what number episode approximately it was?
I can't remember exactly, but it must have been around that time because it was just before COVID, I think, that I had my first show.
I'm pretty sure that you and Sana joined fairly close to the same time frame. So in and around episode 400, I think would be accurate. 496, though. I mean, I still remember when we were discussing how to do the 100th episode, and then we actually did a 150th before we did a big shindig for the 200th, and then it became, blasé, 300 and 400, and now it's almost 500. Wow. Stay tuned, folks, because we have plans that will be in mid-July, 5 episodes from now. Sana, do you want to tell everybody why OPV is taking the night off?
Sure.
Just briefly, because I know you're going to elaborate later.
Yeah, so the observatory is getting 2 new domes tomorrow, finally. They are built and sitting right outside of the Petrie building right now. So if anybody is on campus at York at 9 p.m., you can swing by and take a look at them. And they're going to be craned onto the observatory tomorrow morning starting at about 6 a.m. We're having a couple people come out to watch the domes get craned on and kind of help guide people and make sure they're not trying to come into the enclosure in an unsafe area with, 2 domes swinging overhead. So everyone just kind of needs to get to bed early. And with so much going on, we just decided no observing, no OPV tonight. Let's just make everybody's lives easy.
Sounds fine to me, but yes, a very exciting day tomorrow. And of course, when you say 2 domes up, we've got 2 domes coming down as well, right?
Yeah. So it's going to be in total, 4 domes swinging around in the air.
Yeah. And the forecast calls for clear, and I don't see much in the way of wind because I don't think I would like to see those things swaying around too much.
No, I think the original plan was actually to install them on Wednesday or Thursday, but they kind of bumped that up to Tuesday because Wednesday and Thursday weather wasn't looking that great. So, you want the best weather possible and decided to just get it out of the way now so we don't have to keep renting a crane day by day, just waiting for good weather conditions. So that's why it's tomorrow and not a little bit later in the week.
And the assembly of the 2 domes on the ground has gone very well. That was the other thing too, which, tip of the hat to the Sea West crowd who have been assembling our domes. Anyway, we'll talk more about that very, very soon. For the moment, though, this week in space and astronomy history, Sana, do you want to lead us off? 2009, I think you want to take us.
Yes. So June 18th in 2009, which was the launch of 2 amazing lunar satellites, the Lunar Reconnaissance Orbiter, the LRO, and LCROSS, the Lunar Crater Observation and Sensing Satellite. So these 2 pairs of satellites launched together on an Atlas V rocket taking off from Cape Canaveral, just like I said, on June 18th, 2009, lifting off at 5:32 p.m. It only takes them a couple days to get to the moon, so they arrived a few days later on June 23rd. And that arrival actually marked the first time the United States had sent a mission to the moon in over 10 years, which I hadn't realized. I thought that somebody had been sending probes to the moon even after the manned missions ended, but I didn't realize there had been this long 10-year gap in sending satellites to the moon. So it was sort of a milestone, just breaking those kind of dry spell with this launch. The goals of both the LRO and LCROSS were fairly similar. One of the main things that they wanted to do was just to study the lunar environment. So looking for resources, which included looking for evidence of water ice on the moon. And then they also wanted to test out some new technologies. This would be useful for 2 different things. So both planning for manned and unmanned missions to the moon, investigating the lunar environment, trying to find evidence of water on the moon would be a very, very useful thing for manned missions in the future. Both of these satellites were very successful while they were in operation. The LRO is actually still in use today, and NASA intends to keep it going until it runs out of fuel later in the decade. So a little bit over 10 years in operation, and it's still going strong. It's accomplished quite a few things during its time in lunar orbit, which included being the first spacecraft in orbit around the moon to have laser communication with the Earth. It's also taken some really wonderful pictures of the moon that was used to create the highest resolution map of the moon. It's mapped in total 98.2% of the lunar surface with 100-meter resolution. And the only parts that it's missed are the parts that it just can't see because they are completely shielded from sunlight. Another really cool thing that I think the LRO has done is that it located and imaged landing sites for the Apollo missions and imaged them at higher resolutions, so 50-centimeter resolution. And resolution that high actually allows you to see evidence that humans had actually gone to the moon. So you can see things like the tracks that the Apollo moon buggies left on the moon. And I think this is pretty cool. I've seen the pictures from that the LRO took of some of these landing sites, and they're pretty cool because you can actually see the evidence that humans were there. Unlike the Lunar Reconnaissance Orbiter, the LCROSS mission only lasted about 3 months in orbit around the moon. But this was actually planned. The goal of the LCROSS mission was actually distinct from the Lunar Reconnaissance Orbiter, which that the entire point of this mission was to impact an area of the lunar surface, then have the orbiter fly through the debris cloud that impact made and analyze a bunch of the stuff that got ejected out of the moon's surface. And that's exactly what it did. On October 9th, 2009, it sent the upper stage into impact the moon, and it ejected 350 metric tons of material, making about a 20-meter diameter crater on the moon. Then a couple minutes later, L-Cross actually flew through this plume of dust and analyzed the soil, which led to a bunch of discoveries. One of the most significant ones was that the measurements taken by L-Cross were used to confirm the existence of water ice on the moon, as well as many other materials. So it was a pretty groundbreaking mission, did a lot of really cool stuff, and I honestly think that this sending something in to impact the moon and having L-Cross fly through it is pretty cool. So happy, what is it, launch anniversary to to the LRO and L-Cross.
Just what the moon needed, another crater, right? But other than that, you're absolutely correct. It was a very clever mission. When you think about the differing types of space flights, space missions that have occurred over the years, we have gotten very creative. Normally, you think about missions to other objects, satellites, planets, flybys, orbiters, or landers/rovers. Those are the traditional types of missions. But here is one that was, obviously a hard impact, a crash landing for the main upper stage, but to have an asset fly behind it and fly through the dust plume. And of course, it had literally only, I think you said 2 minutes of glory, right? Because it wasn't very far behind, and its fate was sealed as well. It was on a crash landing trajectory. So it had to do all of its science in literally 2 to 3 minutes. Very clever. And as you indicated, a very successful mission, certainly delivering to us the proof of significant amounts of water ice beneath the subsurface of the moon. Very important as far as human settlements are concerned.
Mm-hmm. Yeah, I wonder if there is any plans to do similar missions to this with the moon, because I mean they did only kind of impact one area, so I'm wondering if there's any plans to maybe do this in a different area.
I've not heard of any future plans in that regard. Certainly now that many differing space entities are able to deploy landers and rovers to the moon. I'm thinking at the moment principally of China, but if NASA has its way, it will be deploying a rover there in the not too distant future with a Canadian instrument on board. It makes a little more sense to put these vehicles in areas where you are suspicious of ice, and then let them go and do their thing in that area. But they can carry on, and it's not just 2 minutes worth of glory. It could be, days, weeks, months worth of exploration that would include checking up on a certain area of ice deposits. So I imagine that is the more likely route that will happen going forward in the next few years.
Yes, that makes sense.
It's a better return for your investment, right?
Mm-hmm.
Okay, all right. On a slightly more sobering story note, June 16th, 1971. First, the good news, the happy news, the really important aspect of history here. Humanity's first space station was launched into orbit. And I will pause for dramatic effect and let everybody think about it there for a moment in listening land. What was the first space station that was launched into Earth orbit? And I'll count backwards just from, say, 3, because I don't want this to drag out too long. But 3, 2, 1, time's up. You should have figured out that by now it was Salyut 1. It was launched by the Soviet Union on this date, June 16th, 1971. After the conclusion, or the effective conclusion, of the space race, because by this moment in time, Apollo 11 and several other Apollo missions had successfully landed on the moon, and the Soviet Union, that's former, it's now called Russia, but the former Soviet Union, had more or less abandoned its efforts to put humans on the moon for a variety of differing reasons, but it just wasn't going to happen. And so they were now focused on sample return missions, which they were doing very well from the moon, and deploying assets into Earth orbit to create space stations, and Salyut 1 was the first space station. It was actually launched on the 19th of April, 1971. June 16th, I should clarify, June 16th was the date when there was actually a fire on board Salyut 1. So Salyut 1 actually launched 19th of April 1971, but the reason that I'm most interested in tonight's story is the onboard fire. More about that in a moment. So Salyut launched. It was basically a I won't say it was a 5-bedroom house because it wasn't. It was a 5-compartment vehicle that was a little bit tight and crampy for the 3 cosmonauts who were on board, but it was nonetheless humanity's first space station. The first crew that tried to dock with Salyut 1 was Soyuz 10, and that did not go so well. Anybody who has watched docking procedures at the International Space Station knows full well that there's sort of like a soft dock, and then there's a hard dock. The soft dock is where they sort of get up close and personal, kiss each other. This is the spacecraft, that is. And then they hard dock. They pull things tight, and they make a nice airtight seal, and then the vehicle that has just arrived is more or less a part of the space station. Well, Soyuz 10 was unsuccessful in creating the hard dock with Salyut, and they basically had to abandon their attempt to journey into Salyut 1. The second crew, Soyuz 11, was far more successful, and they were able to dock on or about June 8th of, actually it was June 5, June 5 of 1971. The 3 cosmonauts, my Russian is not all that good, but Gorgei Dobrovolsky, Vladislav Volkov, and Viktor Patsayev. Those were the 3 cosmonauts who entered into Salyut 1. And so they were the first resident crew. Interestingly, when they entered, they actually smelled smoke. The vehicle was obviously airtight. Nothing had happened on board, but it smelt as if there had been an onboard fire, or at least some electrical circuitry that had, let's say, misbehaved. Anyway, so their first chore on board the space station was to put in new filters and clear out the air so that they could actually survive and breathe it. So that was obviously portents of things to come. At any rate, on day 11, there was an actual smoldering. Now, nobody actually saw flames, but there was obviously a lot of smoke that was coming out of the aft section of the Salyut space station. And this caused a great deal, as you can well imagine, of near panic. I won't say panic, but they were certainly very, very concerned about the situation. And if you ever actually go back and listen to the archives, because at this point in space history, the US and the Soviets were still pretty much at rivalry type situations. There were code words that the Soviet Space Federation wanted the astronauts to use in the event that something like a fire had actually broken out. And believe it or not, the word that they used as code was a curtain. And so apparently the mission controllers who were listening in to the astronauts basically heard the astronauts say, "Mission control, there's a curtain in the spacecraft." And, of course, Mission Control obviously hadn't got the memo because they didn't see the list of passwords, and they basically asked for a clarification from the onboard crew who said, "There's a fire on board." Sounds strange. But anyway, it was a smoldering smoke that was being given off by, it seems, a short-circuiting in the science equipment bay at the back of the spacecraft. So they basically turned it off. It stopped smoldering, it stopped smoking, and everything was fine. But nonetheless, it is actually down in history as the first onboard fire. It just didn't get out of control, which is really good. And the Soyuz 11 crew was able to successfully finish their 23-day mission in Salyut 1. Unfortunately, that crew never made it home. Their Soyuz spacecraft depressurized during re-entry, and all 3 were lost. They basically asphyxiated because the near vacuum of space entered into the spacecraft, and they were not wearing spacesuits at this point in history. So Soyuz 11 touched down, but the 3 astronauts had perished. For the record, they are the only astronauts that we are aware of who actually died in space. They were above the Kármán line, above 100 kilometers, when the capsule basically depressurized.
space travel, especially space stations, started so early on, considering where we are now, as because I guess we see less of them now. We just have the one big one and a couple smaller ones.
It it is an interesting history, Gagan. You're right. I mean, this is 50 years ago, basically. Within a year, so as to speak. It was the upshot, if you will, of the space race. Going to the moon. What's next? And both countries, and there really were only two spacefaring countries at that point in time, the United States and Russia. The space station was really the next obvious step, but it never developed in a way that brought the entire space community together. There was a whole series of Salyut missions through the 70s that morphed into the Mir space station, which was very successful, and that then morphed into the International Space Station. I mean, it took the better part of 30 years from Salyut to ISS for international cooperation and a big space station to actually be built. 30 years, yet we went from nobody in orbit to people on the moon within 10. I think the story there simply is when you have incentive, you can do anything. And when you're asked to sort of, cast around and figure out what you're doing, the process becomes much slower.
Yeah, and of course, the politics about a space race help with funding greatly.
Blank check. Yep. No question in the world about that. It's for sure. But anyway, as I say, Salyut 1 does go down as being our first space station, and it certainly had to overcome some adversity, as did its crews. Happier notes, Gagan. Happier notes. Go for it.
Sure. I've got something a little farther out. Pioneer 10, 40 almost years ago today, became the first man-made object to ever leave the solar system. So Pioneer 10 was the spacecraft that marked many firsts in space travel. It was the first to the outer solar system and also the first Jupiter flyby. And it was an unmanned probe designed as a prelude to other outer solar system projects such as the Voyager missions. So the main goals of the Pioneer missions were to investigate the interplanetary medium past Mars and, investigate the asteroid belt and really determine if what the risks were for space travel past Mars, because prior to that point, nobody had ever gone there. And if it got that far, it also wanted to investigate Jupiter and its environment and see what was going on. So Pioneer 10 was launched March 3rd, 1972, and it went on to visit Jupiter and got the first really good images of Jupiter and its Galilean moons, Ganymede and Europa. And for those images, the program actually went on to receive an Emmy for the release program because the way that NASA decided to release their images was apparently stellar. No pun intended.
You're right.
And it also investigated Io briefly. So it went through the asteroid belt, didn't really face much damage there, and then made its way to Jupiter, where it approached Jupiter, took several images on its way there, images of its moons, and then did a little flyby and stayed in orbit for a little bit. But after it was done with Jupiter, the scientists at NASA had bigger plans for Pioneer 10. They actually gave it a trajectory that would slingshot it around Jupiter and allow it to reach the escape velocity of the solar system. So for any large body in space, or actually any small body in space too, it will have an escape velocity, which is a velocity that an object needs to escape the gravity of that body's orbit and be able to leave its orbit. So this slingshot maneuver that NASA sent Pioneer 10 on around Jupiter allowed Pioneer 10 to reach the escape velocity of the solar system. And in June 13th, 1983, it passed the orbit of Neptune, which at that point was the furthest planet in the solar system. And of course, it still is technically, but it had a short stint at being the second furthest in between. And so Pioneer 10 was on its way out towards deep space. And it actually continued to transmit its location for another 20 years, it's crazy, millions and billions of kilometers away. but its last signal was on January 23rd, 2003. And at this point, in recent years, it has been estimated to be over 16 billion kilometers away from Earth. But interestingly, it'll still take about 20 million years, if it survives that long, to reach the closest star, Proxima Centauri. And it actually, at this point, is not even the furthest object that is man-made out in deep space, because it was most likely overtaken by Voyager 2 in 2019. Of course, we don't really know what's up with Pioneer right now because it hasn't been in communication for 19 years. And we don't know where it is. It could be lost. It could have been struck by another interplanetary, interstellar body and had a collision and been destroyed, but we won't know. But hopefully it's still on its way out there, exploring and being a pioneer as it was made to do.
The grand tour of the solar system in the 70s, led by the Pioneers, followed up by Voyager, those 4 missions really, to me, were the capstones of the 1970s. There were lots of things that happened there. We could talk about Skylab, the first US space station. We've already spoken about the Salyut missions. We could talk about Viking. There were lots of great things that happened in the 70s, but Pioneers 10 and 11, and then Voyagers 1 and 2, to coin the Star Trek phrase, to boldly go where no one has gone before. I mean, that's exactly what they did. We had not ventured beyond the asteroid belt prior to the launch of Pioneer 10, and the number of times that we've gone out beyond the asteroid belt is still very few, yet Pioneers 10 and 11, Voyagers 1 and 2, they did all sorts of wonderful firsts, and 2 of them are still operating. Voyagers 1 and 2 are still transmitting, but the trail was blazed principally by Pioneer 10 and secondarily by Pioneer 11.
Yeah, and having all those missions in such close succession to each other, and it really did wonders for our outer solar system missions in the 80s, 90s, and of course, early 2000s.
Yeah, very exciting stuff.
Yeah, and they visited Uranus and Neptune, or at least some of them did, because those two have been kind of neglected.
I believe that was Voyager 2.
It was.
That did both of them, and I think it's the only one that's done both.
That is correct. January of 86 and August of 89. And both of those extensions, shall we say, required the Deep Space Network here on the ground to be updated and upgraded. When the Voyagers were launched, the Deep Space Network could not communicate with them at the distance of Neptune and Uranus. But fortunately, with the flybys of Saturn in and around 1980 or thereabouts, it gave the DSN nearly 6 years to upgrade itself so that when Voyager 2 got to those 2 planets, they'd be able to talk to Earth. And that's exactly what happened. And we got wonderful imagery. It was, the NASA TV channel, which probably we're all aware of, transmits a lot of material daily these days. Back in the 80s, its programming was a little thinner, shall we say. But in and around the closest approach for those 2 planets, there was continuous broadcast with the imagery coming in from Voyager 2. It was unprocessed by and large, so it was a little it was unprocessed. Let's just leave it at that. It hadn't been tweaked. But to see those raw black and white images of first Uranus and then Neptune in particular. Neptune was a whole lot more interesting than Uranus. Really was exciting stuff. So, you get to do firsts only once. Good stuff. Okay, Summer, where are you taking us?
To Pluto. So out into the outer solar system along with Pioneer.
And Voyager, very good.
Yes. So June 15th, 2005, which is when 2 new moons of Pluto were discovered. Pluto has 5 moons named Charon, Nix, Hydra, Kerberos, and Styx. And interestingly, all of these were discovered in June, but just at different years. Charon, which is Pluto's largest moon, was discovered in 1978, and then the other 4 were discovered using images from the Hubble Space Telescope, all of this data was actually taken in preparation for the New Horizons mission, which reached Pluto in 2015. Nix and Hydra were the 2 moons that were discovered on June 15th, 2005. And they in particular were discovered as part of a search called the Pluto Companion Search Team, whose goal was just basically to find any moons of Pluto ahead of the New Horizons mission. So exactly what the name suggests. Exactly, or almost exactly a year after the discovery of Nix and Hydra in June of 2006, the names were approved by the International Astronomical Union. The 2 moons were named following the typical convention that objects that are in the Pluto system are named after mythological creatures that are affiliated with the underworld. Hydra in particular was named after a creature from Greek mythology that was a 9-headed serpent. And then Nyx was named after the goddess of night and the mother of Charon, who also from Greek mythology. But one interesting thing here is that the way that Nyx is spelled is technically wrong in terms of Greek mythology. It actually follows the Egyptian spelling instead of the Greek spelling. And that's simply because the correct spelling was already taken by another solar system object. So Nyx is spelled with a Y in Greek mythology, but I think it was an asteroid was already named Nyx spelled with Y. So the IAU decided to spell the Nyx, Pluto's moon, as NIX instead of NYX, just to make sure you didn't have 2 objects with the same name. An additional factor for choosing these specific names was to honor the New Horizons mission and the Hubble Space Telescope. The initials of the moons N and H are the same as the initials of New Horizons, and then the H in Hydra can also honor the Hubble Space Telescope, which was used to discover them. A ton of research has been done into the Pluto system and Nix and Hydra ever since they were discovered, so just a few fun facts on the 2 moons. Is that they are both small and very dim, both about the same size, around 50 kilometers across, with Hydra being slightly bigger than Nix. And both of them are about 5,000 times dimmer than Pluto. Along with the rest of the Pluto system, they're also believed to have formed in the early solar system as a result of a collision between Pluto and another Kuiper Belt object. So happy Discovery Day to Nix and Hydra. And I gotta say that I always find it funny how there are some names that there's so much work that goes into figuring out the perfect name. And then there are some other ones that's just a string of like letters and numbers. And there's no in between.
Certainly in this particular case, the naming convention was somewhere between bizarre and rational. That's for sure. You spell, heck, I'm not the world's best speller, but I mean, if you're going to adopt a name, surely it should be spelt correctly. And if there is another object that is already named that, well, guess what? Let's go find a different name. Anyway, what the heck?
The thing is also, I could understand them not wanting to name another asteroid Nix, but this is a moon of Pluto.
Yeah, that's
so
exactly right.
They're distinct objects here. There's no confusing them.
Well, that's also true. That's for sure. When we think back to the excitement in and around the New Horizons mission, it really, captured everybody's imagination. We hadn't been into the outer solar system with a mission like this, as we just indicated, since Voyager 2. So the flyby of Neptune in 89, and here we are 2016-ish, for actually, I guess it was 2015, for the Pluto flyby, and all of the work that the Hubble Space Telescope and others engaged in to make sure that mission would be successful. There's a long time between it, like 25 years, and now it's well and truly in the rearview mirror. Space exploration really does move along at seemingly a slow pace, but when you blink, it's gone, and it's history. And this is a great example of it. The intense observing activity in and around the Pluto system to ensure a successful flyby in 2015, and that was 7 years ago. I still remember when watching the launch. I put the launch of New Horizons, that was in 2006, up on the main viewer in the Curtis Lecture Theatre because it coincided with one of my natural science classes in astronomy, and I wasn't going to let them not see the launch, aka I wanted to see the launch, and so they were going to see the launch. That was 2006. Wow. Oh, gosh.
And even so, by the time the mission launched with New Horizons, and by the time it got to Pluto, Pluto had been declassified, which is, it's not ideal, but it's pretty funny.
If we get hate mail from Ariella anytime soon.
I'm sure it'll have my name on it. I think I've mentioned Pluto's declassification 3 times now.
I won't show her the assignment you gave your class where you talk about 8 planets in the solar system.
Oh, no, please don't. I'd like her to keep me on her Christmas card list. Yes, please. All right, let's move along, ladies. June 13th, 2010, the JAXA mission, that's the Japanese Aerospace and Exploration Agency, launched Hayabusa 1. Well, actually, more to the point, Hayabusa 1 returned to Earth on June 13th, 2010. They launched it on May 9th, 2003. Hayabusa, which means peregrine falcon, by the way, had its primary mission to go out and do sample return on a near-Earth asteroid by the name of Itokawa. So this was one of the first missions to go and grab a sample from an object other than the moon. We'd done it to the moon many times, but we had never gone off to an object and picked up samples and bring them back. You might recall the Stardust mission. It went through the solar system with basically an aerogel tennis racket and picked up cometary debris. But that was different, if you will, to picking up sort of soil samples from an asteroid. So Hayabusa was charging off using lots of new technology, ion thrusters and so on, and was going to do a touch-and-go type of scoop of the soil from Itokawa. And so this was a very ambitious mission. It arrived in orbit around Itokawa on the 12th of September 2005. Unfortunately, the touch-and-go sample retrieval didn't quite go according to plan. And again, as a portent of things to come, the Hayabusa craft was deploying a little rover and another little satellite by the name of Minerva that was supposed to go to the surface of Hayabusa and then sort of bounce and jaunt around on the surface. It missed. Okay, so poor little Minerva went floating off into space. Very sad. So Hayabusa itself then prepared for the touch and go. It went down to the surface, kissed the surface. There was some bullet propellants that were launched into the surface with the aim of scooping up material that was going to get caught by a big sort of bell that was over the soil when the bullets were fired into the surface. And then the spacecraft was going to back away and bring that back to Earth and dump it into the Australian outback. That was the plan. They actually did get to the surface. It certainly appears as if the bullet propellants did not fire into the surface. Nonetheless, we were able to scoop up some sample of Itokawa, but in the process of Hayabusa backing away, all heck broke loose. Without going into long and gory detail, this is JAXA's most successful failure or most successful near failure because the ion thrusters developed a leak. We lost the stabilization of the spacecraft. JAXA fought tooth and nail to get the vehicle back under control in the ensuing year, but they succeeded. And then instead of it returning back to Earth in 2007, they managed to successfully bring it back in 2010. As I said, it was really a phenomenal effort by JAXA to bring Hayabusa home and pick up the sample return capsule on the Woomera rocket range in the outback of South Australia, because that's where it ended up. The re-entry of Hayabusa into the atmosphere was absolutely sensational. There was lots of imagery done because it happened at night, and when we picked up the sample return capsule, opened it up, of course, in clean nitrogen-filled rooms and so on. There was about 1,500 grains of soil that were picked up. Not very much. We're really only talking milligrams of material instead of tens, if not hundreds of grams of material that was expected. But nonetheless, the sample of the materials picked up were definitely from Itokawa. They really resembled meteoritic dust more than anything else. But it's the story of how they got Hayabusa home, which is really the highlight of this mission in many ways. They took the success of Hayabusa, and Hayabusa 2 went charging off to an asteroid. Actually came back about a year or so ago now. Its name eludes me. I can't remember the name of the asteroid that Hayabusa 2 visited, but they took all of their experiences from Hayabusa 1, corrected all of the problems in Hayabusa 2, not only deposited back many tens, if not hundreds of grams of its sample return, but the Hayabusa 2 bus is still operational and has been retargeted to other parts of the solar system. So 3 cheers for JAXA. Its return of Hayabusa 1, June 13th, 2010.
Is this the same sort of thing that OSIRIS-REx did?
Yeah. Is doing, yes. OSIRIS-REx went to asteroid Bennu, and it is on its way back. It will land next year, not in Australia. I believe it's meant to land in Utah, but it's exactly the same mission. The Hayabusa 2 and OSIRIS-REx were were launched more or less simultaneously. Both were sample return missions from differing asteroids. Hayabusa is back, and OSIRIS-REx is coming back.
Is it stopping off at another target? I seem to remember reading something about that.
No, OSIRIS-REx is on its way home, period.
Okay. Okay.
The scientists, including folks from York, really want to see that material. They feel as if they've got about 2 kilograms of material on board OSIRIS-REx. So if that, in fact, is the case, that will be a real treasure trove for geologists around the world. And the folks down at the ROM will get to share in the glory of that and some of the analysis as well. So Neil Daly from York and the folks from the ROM, very, very excited to see OSIRIS-REx return.
Yeah. I also have I have a question. You said that they opened the samples in nitrogen-filled rooms. Mm-hmm. Why is it nitrogen?
Unreactive gas, unlike oxygen, which tends to oxidize things, which is not cool.
Are there any other gases that do the same thing? You can see I've forgotten my chemistry.
Well, they could probably have used argon. It's just more expensive.
Okay, that makes sense.
Yeah, argon and nitrogen tend to be the 2 gases which they use in these sorts of situations so that there is no expected reactions associated with the soil samples. They did the same with the Apollo moon rocks as well. They opened them up in nitrogen-filled environments.
Oh, that's interesting.
Yeah, and we have a vast abundance of nitrogen that we don't have of much else, I guess.
That's exactly right. Hence, as I say, cost. Okay, Gagan, finish us off so we can get to the dome story.
Yes, of course. I'll make this one quick. So June 10th, 2003 is when Mars's rover Spirit was launched. And Spirit was the first rover to land, not in general, but as a part of NASA's Mars Exploration Rover series, which consisted of Spirit and Opportunity. So it was launched in 2003 and landed on Mars in January 2004. And the mission's goals were to explore the Martian surface and atmosphere, and it was mostly geology related. They wanted to see what the makeup of Mars, the Martian surface, was like, whether there was water on the surface, of course, the question that's been asked basically every Mars mission that's gone there. And it was planned to rove around for 90 sols, which is a Martian day. And a Martian day is a little bit over an Earth day, but that's, I think, on the order of less than an hour. So there's not much difference between a sol and a day. So 90 sols was just over 92 Earth days. And The mission actually ran a lot longer than its expected mission duration. So the expected mission duration was 90 days, and it ended up working for over 3 Mars years, which is the second longest Mars rover that remained operational, second only to Opportunity. Of course, we do have now some rovers that are currently operational that might break these records, but that is yet to be seen. So it was also only planned to drive 600 meters. It wasn't really planned for some long distance traveling on the Martian surface, but being an overachiever, it actually ended up driving over 7.1 kilometers longer than it was originally targeted to travel, and ended up going almost 8 kilometers. So it was given an inch and it took a few miles. It delivered many images as well of the Martian surface, some of the first really high quality images, and even captured a dust devil on the surface. And it also imaged Phobos and Deimos, the Martian moons, from the Martian surface. So we got a lot of really cool data from Spirit, but it unfortunately got stuck in sand at around the 3-year mark, and eventually lost comms because it was unable to get out of the sand. And eventually, with sand covering the solar panels, it was unable to power itself up. And the mission was eventually retired in 2011 after Spirit missed a standard communications check. So after it lost comms, it was actually first the mission changed into Spirit being a stationary communications center. But with the loss of power and gradual decrease in functionality, the mission was retired in 2011. And then the Opportunity mission actually lasted a lot longer, almost double the length that the Spirit rover lasted. But that mission is now also retired.
Just one tiny clarification before we move on. It was the Martian winter that actually did Spirit in. You're right, it got stuck in a sandbank, and the soil that was covering the solar panels made the conversion of solar power into electricity decreasingly good, shall we say. But when the Martian winter struck and the nights went down to minus 80, minus 90 degrees Celsius, that's when the power drain became critical, and the system failed as a result of the starvation of solar power to feed the battery warmers that would keep the computers alive. Yeah, the saga, the loss of Spirit, was a little heart-wrenching for those of us who were watching it day by day, because the NASA engineers tried desperately for a full year to get it out of the sandbank, or at least tip the solar panels into a more optimal orientation for solar energy collection, and nothing they could do solved the problem. It was really, really sad. Folks, you're listening to York Universe, the weekly broadcast of astronomy and astrophysics out of the Allan I. Carswell Observatory. Sana, Gagan, myself, Paul, keeping you company this night in Astronomy Night in Canada. By all means, turn your favorite web browser to observatory.info.yorku.ca and have a look around our website for all the exciting things that are happening. That includes a rerun episode for our Wednesday night online public viewing program on Teletube. But speaking of activities at the Dome, Sana, do you want to bring us up to speed on the excitement that starts tomorrow morning at 6:30 local time?
Sure. So yeah, as I mentioned earlier, tomorrow is going to be a huge day because we're finally getting 2 new domes. The domes that are currently on the observatory are the original domes from when the observatory was built in 1968, I believe.
Correct.
So they are over 50 years old and really about to die. We kind of have desperately been needing new domes for the past few years. I remember when I started here, the domes were functioning okay, but year by year, they've kind of gotten progressively worse. They really can't handle the cold. The motors and some of the equipment just keeps breaking and needs to be repaired a lot. So after a very long process, we are finally at a point where we have 2 new domes ready to go on tomorrow morning. So just a bit of information about the domes themselves. They are made by the same company that made the domes that we currently have, Ash Dome, but these are an updated model. MEBH is the model code. I'm not sure what other model domes that Ash Dome has, but these are the ones that we're getting. And they have a lot of amazing perks over the domes that we have right now. So one of the great things about these is that the bottom shutter on this dome is kind of independent. The way it is right now, we have to, if we want to observe something low on the horizon, you got to bring the bottom shutter up. But then if you want to observe something at the zenith, you have to bring the whole dome down, lower the shutter, and then open the top shutter again so you can observe. And then we have this annoying string that hangs down from the dome so that we can actually control that, that sometimes runs into the telescope in the 1 meter. But we're not going to have to deal with that anymore because the dome actually opens at the bottom. It's like some hydraulic door that opens at the bottom on its own. So it kind of, when you open and close it, it kind of looks like it's eating something. But that's very exciting, so we won't have to deal with any of those bottom shutter issues anymore. The domes are also going to be fully programmable. So with some time and a lot of work from observatory staff, they are going to be able to operate completely independently. So we can just kind of actually program it to observe multiple targets in one night without us actually being here to observe, which is another huge perk. And we can also set it up to observe things like targets of opportunity, like supernova or asteroid transits, again, without us being around. We can program it and it can just kind of do it itself. So very exciting, very, very exciting day tomorrow. The domes are going to get craned in at starting around 6:30 a.m. If you're around campus at the time, you can watch it, but you just have to kind of stand behind a perimeter that's been set out. But very, very exciting tomorrow morning.
Just to give everybody a little bit of a sense of weight, each of these new domes weighs in, I believe, Sana, at about 6,000 pounds. That's about 3,000 kilograms.
Oh, wow.
Yep.
I actually got to push them the other day, and they did not feel that heavy.
That's true. The track that they roll on is very well balanced and very well greased. These two domes, as you say, from Ash, are definitely state-of-the-art domes, and they will complement the 1 meter telescope absolutely beautifully, and they will certainly enhance the capabilities of our 60 centimeter telescope, which is original. The 60 centimeter telescope went into the original domes back in 1968. The 60 centimeter was from a group called Competition Associates, went in at the same time as a 30 centimeter telescope. Both were research grade telescopes there in the 1960s. The 30 centimeter was eventually replaced by the Meade LX200 40 centimeter telescope in December of 99. But that telescope, of course, is now over on our Arboretum facility, leaving room for the 1 meter from Planewave, and that went in August of 2019. So there's been some wonderful history associated with the observatory, but definitely these two domes being craned into position tomorrow will increase the opportunities for observing for all students and for all researchers.
Mm-hmm. I'm so excited.
So you and Gagan will be able to do the next Messier Marathon March of next year. It'll be so much easier.
Yeah, no one has done a Messier Marathon since we did it in 2019. So
and I think we were the first.
Yeah, yeah. So we need to get together again for the second Messier Marathon.
You know, I'm 100% down to do that next March.
Mm-hmm. Yeah.
To be fair, COVID did get in the way for observing with Messier marathons, but still, you two ladies were the first. There were several team members in the past that certainly observed a large number of Messier objects in one evening, but nobody attempted a Messier marathon prior to what you did in 2019. And you got, what, 80 of the 110 objects?
Something like that, yeah.
No, I think we actually got up to almost 100.
Oh, really?
Like in the 90s.
Oh, okay, fair enough.
We got a lot of them. Yeah,
we were. Sorry, go ahead.
Now go.
Sorry. I think we were limited by COVID that year because Sana and I went up, and on the very last day that the campus was open, on March 14th, I believe, and that was a Sunday night, and by morning on Monday, the campus had been shut down because of the COVID pandemic.
Yeah, I remember when we were planning to do the Messier Marathon, they had just suspended a bunch of in-person activities, so we couldn't be open to the public anymore, and it was supposed to be just an observatory staff thing. So we went and did it, and then a couple days later, the entire school shut down. So, I mean, it was pretty good timing.
Yeah, we had to, I think we weren't even in the window, because I remember an email from Paul saying, you guys better, because I think we discussed and planned it a little while in advance. And then there was that email about nice weather this weekend, but it might be your last opportunity.
And it was. And you took it.
It was. Yeah. Yeah, that was a very chaotic night. We were speed running those objects.
Oh, yeah.
Well, next March.
It was a lot of fun.
Next March, when you do it again, you'll have an even better time of it with such a beautiful dome. And, of course, the 1 meter telescope working in concert with that dome. So, yeah, big day tomorrow and lots of terrific observing ahead once all of the I's are dotted and the T's are crossed. And Elena Hyde, of course, has been working terribly hard to make all this work. This has been a labor of love for pretty well the last year. And now it is all coming together. So very, very exciting.
Will either of you be here at 6 a.m.?
Not at 6 a.m. I lecture tomorrow, so you'll see me about 9:35. So I'll miss some of the action, but I'll guarantee that not all domes will have been removed and all domes will have been replaced by 9:30. If you have, I will be disappointed, but c'est la vie. But I'm fully expecting to see some action at 9:30.
Yeah, I think she said that if everything goes according to plan, which I mean it never does, that the old domes should be on the ground and new domes should be sitting on the domes by 9, possibly till 11, or it might possibly take till 11 or 12, which I think is more realistic.
I think it is too. I mean, I'm fine if they are successful by 9 o'clock. So be it. I'll just ogle at the new domes on top of the observatory tower, and I can live with that. But as you say, Sana, nothing ever goes according to plan. There will undoubtedly be little hiccups here and there as everybody is being very cautious in the processing of that, and then we will see everything brand new. Let me just give a quick little update for the planetary alignment because we're approaching the top of the hour. Everybody out there is probably aware that Mercury, Venus, Mars, Jupiter, and Saturn, in that order, are available in the morning sky. Mercury is very close to the horizon. Greatest western elongation, in fact, is this Thursday, 23.5 degrees. So if you've got clear skies, I strongly recommend everybody get out around about 4:30 in the morning, maybe 5, Eastern time, and have a look towards the eastern horizon. You'll see Mercury hugging the horizon, brilliant Venus just a little bit above it, and use that as your signpost. And then follow the sweeping arc towards the south, picking up bright Jupiter, sort of fairly dusty, not so bright Mars, brilliant Jupiter, and then a little bit of faint yellowish Saturn. All easily visible to the naked eye, all beautifully arrayed along the ecliptic. It's not going to happen for another 20 years. This is a great opportunity to see solar system motion in action. You can see the ecliptic plane spread across the sky beautifully. And on or about the 23rd, the moon, the crescent waning moon, will photobomb the area. So this is a great few days, the next 10 days, to look at this terrific planetary alignment. And it's reasonably warm out. We're at the top of the hour, folks. It's 10 o'clock. It is time for us to sign off. Stay tuned, though, please, for the rest of Astronomy Night in Canada, Western Worlds, Quirks and Quarks, not to mention Science for the People. This has been episode 496. Stay tuned. 5 episodes to go, 4 after this, before we get to 500. So from me, good night and happy dome raising tomorrow to the observatory team.
Good night.
Good
We hope
night.
that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.
AFM.